Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about a few basic concepts on graphs. In our previous classes, we have done some basic classes. Please watch those classes and come back here. The link for the playlist is provided in the description below. Coming to today's class, the first concept is walk. What is meant by walk on a graph? So, with the graphical understanding, with graphical example, we can easily understand what is meant by walk. Then we come to the definition, because definition is a bit confusing. Let's try to understand graphically what is meant by walk. Walk means, see, when you start here V1, from here we move to V2, then we say it as a walk. We are walking on the graph. From V2 we move to V3. V3 we move to V4, V4 we move to V2 again, then we move to V5. This sequence of steps we taken on the graph, we call it as a walk. So this can be shown, a walk can be shown as a, now coming to the definition, a walk of a graph G is defined as an alternating sequence of vertices and edges. Alternating sequence of vertices and edges. What's that mean? We started from V0 and we moved on edge E1, then we moved to V1 vertices V1, then we moved on edge E2. This is what alternating sequence of vertices and edges. We start with a vertex and end with a vertex. So it is shown as an alternating sequence of vertices and edges that begin and end with vertices, such that each line EI means each edge EI. What's that mean? E1 is incident with Vi minus 1 and Vi. Means E1 is an edge between V0 and V1. E2 is an edge between V1 and V2. That is what this statement says, such that each line EI is incident with Vi minus 1 comma Vi. Vertex Vi minus 1, previous vertex comma Vi. This is what the definition of a walk. So simply, you no need to write like this. We can also write it as, it is also denoted using sequence of vertices. V0, V1, we moved from V0 vertex to V1, V1 to V2, so on up to Vn. This is how we can mention. Let's take an example. See, this is a simple walk. So from V1 we move to V2, V2 to V3, V3 to V4. This is called as a walk. Now coming to the next definition, what is meant by a trail? A walk is called as a trail when we say it as a trail if all its edges are distinct. All the edges are distinct means we are not supposed to take the edge repeatedly. We have to take edge only one time. Then we call it as a trail. Similarly, the next definition is path. A walk is called path if all its vertices are distinct. Means we are supposed to take a vertex only one time. We are not supposed to take a vertex multiple times. Then we say it as a path. With example, you will get clarity what trail and path means. Let's take this. We started from V1, we moved to V2, we moved to V3, then we moved to V4, again we moved to V2. See, V1 to V2, V2 to V3, V3 to V4, V4 to V2, V2 to V5. Here V2 is a vertex which we repeated, but edges are not repeated. This edge, next this, next this, next this edge and this edge. Edges are not repeated. If edges are distinct, then we say it as a trail. We cannot say it as a path because V2 is repeated twice. Similarly, if vertices are not repeated, we say it as a path. V1 to V2, V2 to V3, V3 to V4 is a path. Simply, from the graphical understanding, you need to understand if vertices are not repeated, then definitely edges are also not repeated. We are not supposed to take the vertex multiple times. Then definitely we are not going to take the edge multiple times. It's included. That is what you need to understand. So that's why this statement is true for a path and trail. Every path is a trail. Yes, we can say it as. But every trail is not a path. So this is very important to understand. Now coming to the next definition, closed walk. What is meant by closed walk? A walk whose starting and ending vertices is same, we call it as a closed walk. Means, if you take this example, we start from V2, we move to V3, then V4, V5, again V2. We starting and the ending vertex is same. Then we say it as a closed walk. Now coming to understand the definition of circuit. A circuit is a closed walk where edges are not repeated. You are not supposed to repeat the edges. But you should move in the closed walk. Means starting and ending point is same. Then we say it as a circuit. See, in this example, these are the vertices. We started from B. We moved to C. And we moved to F. Then we moved to H. Then we move to C again. Yes, you can take vertices can be repeated, edges are not going to be repeated. Then we take D. Then again move to B. Starting and ending is same. Then we say it as a circuit. Similarly, the next example is a cycle. A cycle is a closed walk where vertices are not repeated. The same thing here. Cycle means you are not supposed to take the vertices again. See here, in the above example, we started from A, C, D, B, A. This is a cycle where vertices are not repeated. Then we call it as a cycle. Hope you understand this definition, simple definitions. But if you want to do coding for all these things, this coding part will be discussed in our design and analysis of algorithms playlist. If you want the coding part, please visit our playlist, Design and Analysis of Algorithms. Hope you understand these basic concepts. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.